Hello, and welcome to Excel 2016. My name is Sean Bugler, and today we're going to be going over some of the more advanced features inside of Excel 2016. Let's go ahead and get started. Now, as we're looking at this data set here, it's interesting to see how this has already been set up. Now, there's a couple of things that we need to take care of before we go any further. We're looking at a couple of sales figures here from February of 2015, and we need to calculate the totals for each individual salesperson. Now, I know full well that we're all capable at this stage of typing in an equal sign, summing up, just like that. But I'd like to introduce a concept to you guys today that's going to come in handy not just for this particular exercise, but for many of the things that we're going to be doing in later lessons. It's nice that we're able to tell Excel, hey, just sum up this range of cells. But at the end of the day, the problem is, we're still trying to speak to Excel in its own language instead of speaking on our own. If we were going to ask somebody to sum up how much S jobs sold between weeks 1 and week 4, we would say, hey, can you sum up S jobs sales? Not B5 through E5. So why do we have to do that for Excel? Why can't we say, hey, sum up S jobs and have it know what we mean? In fact, we can. This is called named ranges. And to create them, we're actually going to need to dive into the Formulas tab. Go ahead and join me here inside the Formulas tab. And we're going to find the Defined Names command group. Now, the Defined Names command group is here because in most instances, named ranges are for formulas and functions. In fact, that's where they come in handy the most, and that's where we'll be using them the most. So keep that in mind when you're trying to remember where the Defined Names command group is. Where do you use them? Inside formulas and functions. So you'll find them in the Formulas tab. What we'd like to do is tell Excel that these 4 cells, B5 through E5, are S jobs sales. So go ahead and highlight from B5 to E5, and we're going to use the Define Name button, which allows us to define the name of a selected field of cells. Give it a click, and check it out. It's automatically guessed that we're going to name it S jobs, given the fact that it was the cell with text immediately to the left. Now, it's not always going to guess correctly, so do make sure that you double check that before you click OK. However, you don't have to use that name. You can always type in your own. It is important to remember, however, that spaces do not play nicely inside of named ranges. Notice that even in Excel, it's placed in some underscores. The next thing we're going to need to keep in mind is the scope. Where are we going to be using this named range? By default, it's going to expand this to the entire workbook. However, we can always limit named ranges to specific worksheets instead. However, for the purposes of this class, we're going to leave it as workbook. You do have the option of putting in comments if you'd like, but in this case, I'm going to go ahead and leave it blank. It is important to note, however, that these can be incredibly useful, especially if you're going to be creating lots of named ranges. The last thing is the Refers To field. This is where you can make any last-minute edits in case it missed a couple of cells. In this case, by clicking inside the box, I can see that the dancing ants are around exactly what I want. So I'm going to lock it in by clicking OK. It's a little anticlimactic, and in fact, it doesn't seem like a lot's happened just yet. But rest assured, what we've done now is we've told Excel that these 4 cells are S jobs. So now I can place my cursor inside the totals field, and just like with any function or formula, I'm going to do my equals, sum, open parentheses, but this time, instead of selecting the cells of the range, I'm going to go ahead and press the F3 key. And check it out. There's S jobs. Go ahead and find S jobs and double click to add them to the list. You'll see that S jobs is now available. By closing out the parentheses, I can complete the sum, and by pressing enter, you'll see now it's taken all 4 cells that I told were S jobs, and it's summed them up. There's my function. Pretty cool. Go ahead and pause the video to catch up to me here. Once again, the way we created that was by highlighting the cells we'd like to name, navigating up to the Formulas tab, and using the Define Name tool to define the name as sjobs. From there, we simply, in the totals field, typed in equals sum, open parentheses, sjobs. Go ahead and try that for yourself, and then come back. Welcome back. So you've gotten your first taste of named ranges. But I can hear your concern. Some of you might have tried to autofill down, and you'll notice that when we did, it simply replicated some sjobs. Wasn't quite what we hoped it would be. It's important to note that this isn't necessarily a real-world use case. This is simply an introduction into what named ranges are. Rest assured there are plenty of real-world use cases we'll be going over in the next couple of lessons. Another concern that tends to pop up during these lessons is there are 5 other individuals here. Do I really have to go in row by row to define these names? The answer is yes and no. Yes, if you want to. However, no, if that feels like a waste of time. If you'd like to get this over with, and believe me, I would too, we're going to go ahead and highlight the remaining values, starting this time by including the salesperson's name. So I'm going to click and drag from eMusk all the way down to the final sale value of $10,252. This time, instead of using the Define Name tool here in the Formulas tab, I'm instead going to find the Create from Selection button. It's important to note that this tool only works if there are row labels or headings. In this case here, I'm going to go ahead and click Create from Selection and check it out. Where are the names that it's going to create from? Are they on the top row? Not so likely. However, they are in the left column: E. Musk, W. Buffett, M. Mayer, S. Sandberg, and so on. So those are our names. Let's go ahead and click OK. Yet again, at first glance, it doesn't look like a lot's happened. But let's take a look and see. Just like in the last process, I'm going to go ahead and start by calculating E. Musk's total sales. I'm going to start with my equal sign. Now I can use my F3 key and pick the name from the list because check it out. Hey, that Create from Selection created all of them in 2 clicks. But I can also use the Use in Formula dropdown available in the Formulas tab. By clicking on that, I can choose another named range from the list. For those of you with computers that don't have a functional F3 key, you can always use the Paste Names field from this as well, and that'll pop up the Paste Name box. Either one will work. In this case here, I'm going to go ahead and select from the list E. Musk. Don't forget my sum. Close out the parentheses. And there we go. So go ahead and take this opportunity to catch up here, and then calculate the remaining values for W. Buffett, M. Mayer, S. Sandberg, and A. Arenditz. Go ahead and pause the video and catch up. Welcome back. So already, hopefully, you're starting to see that creating named ranges is easy. A little too easy, really. And in fact, because it's so powerful, you're going to increasingly see its value as we go through this process. The next thing we're going to need to do is calculate the total sales and average sales. Now, in order to calculate those, of course, we can go through our standard process, but for the sake of practice, we're going to use named ranges yet again to sum up total sales and average all sales. So go ahead and highlight everything in the totals column, from sjobs down to A. Arenditz. And once you've done that, inside the Formulas tab, go ahead and use the Define Name button to calculate February totals. This time I'm going to go ahead and add on to this already pre-filled name. So now I've got my February totals. I'm going to go ahead and click OK to lock that in. And now I'm also going to go ahead and highlight everything from week 1 to week 4. Having highlighted that, there's not really any place for me to create from selection because this time there is no header. So I'm definitely going to have to define a name here. And in this case, I'm going to go ahead and call this All Sales. And click OK. Now that I've created those two named ranges, I can now calculate the total and average sales. Here in total sales, I'll type equals sum, and then using either the F3 key or the use in formula dropdown, I'm going to select February totals and close out the parentheses. And likewise, I'm also going to, in the average sales field, type my equals average, open parentheses, and then select all sales from the use in formula dropdown. Close out the parentheses, and it'll lock it in. Another benefit of having used these name ranges is that now these formulas are practically in English, meaning that I can glance at any one formula and find out exactly what totals I used, what numbers I used, where these data points are coming from. Go ahead and pause the video to catch up with me here. Once again, we created two named ranges. The totals named range, which we then used to sum up total sales, and the all sales named range, which we used to calculate the average everyday sales. Go ahead and catch up to me, and then join me after the pause. So that's your first taste of named ranges. Don't forget it. Rest assured that this is coming back very, very soon. In the meantime, let's shift gears. We've calculated all the total sales. In fact, we've calculated the total sales and average sales for all of February as well. What we'd like to do now is complete the rest of the data set. Now, currently it's asking, was the goal met? And as I look around, I see there is a monthly goal of $34,000. So, let's take a look. In regards to S-Jobs, S-Jobs sold $36,245. Compared to a monthly goal of $34,000, I think it's readily apparent that S-Jobs did in fact meet the goal. So I guess I just type yes, right? We did it! What's the problem with this? Why can't I just type yes? Well, the problem is, I didn't tell Excel how I knew that the goal was met. I just told it that it was. The problem with that is, let's say I turn this into a template and use it next month for March 2015 sales. Well, if the numbers update and let's say S-Jobs doesn't do as well, and the sales drop below 34,000, that cell is going to continue to say yes. So it's not necessarily doing exactly what I hoped it would do, but I thought Excel was smart. It should have known, right? Not yet. We've got to tell Excel how we got there, and how we got there was by using logic. So let's teach Excel the logic we used. In this example, we're asking a question. Was this cell greater than this cell? Did the total beat the goal? In order to ask that question to Excel, we have to posit it in a very specific way, in a very simplistic way. Basically, we have to ask, is something true or not? And to do that, we have the if function. The if function allows us to ask Excel a question and, depending on the response, respond accordingly with either if true, do something, or if false, do something else. So let's go ahead and type our first if function. Now I know many of you who already work with functions are comfortable typing these functions by typing equals, if, but you've actually been doing it the hard way, not the wrong way. And in fact, if after this lesson you decide to continue doing this the exact same way you've always done, that's fine. But I'd like to show you guys a new way to inject functions, especially complex functions, into Excel. Placing your cursor in cell H5, we're going to go ahead and find the Insert Functions tool. This can be found to the left of the Formulas tab. By clicking on the Insert Functions button, you'll see a little search field. I'm going to go ahead and search for if. And once I've typed if, I'm going to click Go. This is an actual library of every single function inside of Excel. By typing if into the search function and clicking Go, I can bubble if up to the top. And on top of that, I actually get a description of what if actually does. And where better to get a description than from the people who actually wrote the code. In this case, Microsoft describes if as checking whether a condition is met. and then returning one value if true and another value if false. Makes sense to me. Once you find the if function, go ahead and click OK, which will bring you into the function arguments box. The function arguments box exists for every single function inside of Excel, even the simplest ones like sum. What it does is it compartmentalizes each individual part of the function into its own little box. This allows you to focus on one individual part of the function at a time, allowing for the utmost focus and control. As we go through this here, you'll see the benefits. The first thing it's asking for is the logical test. Now, if you're not entirely sure what the logical test does, you can always look down here at the bottom. No matter where you are, if you click inside the box, it'll tell you what that box is asking for. In this case, the logical test is any value or expression that can be evaluated to true or false. This is our question. In this case, the question is the total cell greater than the monthly goal? So let's go ahead and take that into account. I'm going to just click on the total cell. So F5, was it greater than or equal to I2? And interestingly enough, because we're inside the function arguments box, it's actually automatically answered that question. In this case, F5 is greater than I2, so we know, because it says true, that our question is right. The next thing it's asking for is the value if true field. What do we want Excel to do if the cell is true? If the question is true, we probably want the box to say something like yes. So let's go ahead and type yes. However, it's important to remember that you can't just type text into a function. You have to remember that if you're typing an actual text field that's not a function, you need to surround it with quotations. Once you've done that, go ahead and tab down to the next field. So, if the question is true, the box should say yes. However, if the question is false, what do we want the box to say? Now, usually the response is no, but let's have some fun with it, right? How about not a chance? Notice I remembered to put quotations in there. Now, what's the scariest part about building a function? For those of you that have built them in the past, you might answer that the scariest part about building a function is remembering all the commas and the parentheses. However, with the function arguments box, you don't have to remember the commas or the parentheses. This box takes care of it for you. In fact, take a look at the formula bar. This is the function we just built. Notice it took the commas and the parentheses into account already. Nice, right? On top of that, before we even click OK, we can even see whether or not this function is going to work. So no more holding your breath before you tap the Enter key. Simply look in the bottom left corner by the formula result, and you'll see exactly what the cell output will be. Now, of course, if you're seeing an error here, you should double check to make sure that your boxes match mine. Once we've asked the question, we've got our value of true and our value of false responses. Let's go ahead and click OK. And there you go. Was the goal met? In this case, the answer is yes. 36,245 is greater than the monthly goal of 34,000. Go ahead and pause the video to catch up. Once again, the way we got there was by using the Insert Function Arguments box, which can be found in the Formulas tab on the far left-hand side. This tool can also be found here, to the left of the formula bar. These are the same tool. One is just a little bit more accessible than the other. Once you open the Function Arguments box, simply make the changes that you need to, ask the question, input your response if true, your value if false, and click OK. Go ahead and pause the video and catch up. All right, welcome back. So at this stage, we've asked a single question. Did SJobs meet the monthly goal? In this case, the answer was yes. Now, none of us want to have to rebuild the same function over and over and over again. Thankfully, of course, we have autofill. So let's go ahead and take a look at that. By placing our cursor on the bottom right corner of the active cell that has the formula we'd like to copy, we're simply going to ensure that we've got that thin black cross, click and hold, and drag until we get to the bottom of this box, and then release. Now at first glance it looks like it works, but of course, as any good mathematician will tell you, never trust your own work. So let's take a look. Go ahead and place your cursor on the first cell, the one that we built. Okay, so we've got 36,000, that's greater than 34,000, good. 31,000, greater than 34,000? No, it's not, but what's going on here? Why does it say yes? In fact, as I'm going through this here, I'm seeing in a couple of instances it's saying yes when it should not. In this case here, unfortunately, S. Sandberg did not do what we hoped they would do. Oof, missed it by $1. But it still says yes. Now, either the computer's being generous or something's gone wrong. In any case, we're going to need to take a deeper look at this. And for that, we're going to need help. To analyze all of our formulas that we built, we're going to need access to some of these formula auditing tools. Let's go ahead and place our cursor on the first cell. Now, this is the cell that we built, so we'll use this as a test run to make sure that we know everything's working. Go ahead and find the Trace Precedence button and give it a click. And check it out. This is a visual indication of where this cell and its function are pulling reference data. In this case, this cell is referencing the totals field and the monthly goal field. Okay, everything looks good here. I'm going to go ahead and go down to the next cell here. And once again, we're going to trace precedence. Huh. That's weird. When we built the function originally, we were asking, does the total exceed the monthly goal? Then why is it that when I trace precedence here, it's asking, does the total beat nothing? Because of course the answer is yes for that. Let's take a look at the cell below, and once again we're going to trace precedence. And now we're starting to see the problem. When we auto-filled down, we didn't remember to absolute reference the cell. For those of you who aren't familiar with absolute referencing, refer back to earlier lessons. But for those of you who are, what cell in this formula shouldn't have changed? If you said I2, you'd be absolutely right. Each total cell should be referencing 34,000 no matter what. And in fact, if we click on the Show Formulas button, first things first, let's get rid of these arrows. Go ahead and select Remove Arrows. And now let's show formulas. This is going to reveal all formulas inside the worksheet. So as we're going through this here, we see that when we autofill, because we didn't absolute reference, F5 became F6 became F7, which is right, because we wanted to continue referencing each total one row after the other. However, I2 should never have become I3, which became I4, and so on. I2 should have always stayed I2. So we have to fix that. To fix that, go ahead and place your cursor either on cell H5 and double click, or click on the cell and in the formula bar, go ahead and place your cursor on top of I2. Now, it's a small change, so we won't need to do anything too crazy. We're simply going to place our cursor on cell I2, the cell that shouldn't have changed in the first place. And we're going to absolute reference it using our keyboard shortcut of F4. Once again, noticing that when you tap the F4 key, we now have $signs on either side of the column value and the row label. We've now absolute referenced the cell, meaning that when we autofill, Excel knows that I2 should always be I2. Go ahead and press Enter to lock that in. We're now going to autofill this down to ensure that this works the way we expect it to. By clicking on cell H5, we're now going to autofill down all the way to H10. Once again, turning my fat white cross into a thin black cross, I'm going to click and drag down to the very bottom, and there we go. So now we see F5 to I2, F6 to I2, F7, F8. Everything is now working the way it should. Let's go ahead and unshow formulas. Simply click the Show Formulas button once again, to resolve it back to its original view. Let's double check. 36,000 is greater than 34, so yes. 31, not greater than 34, so not a chance. Okay. 33, good. All right. So it looks like by absolute referencing cell I2, we managed to salvage the function. And we didn't have to build all the rest of them ourselves. We allowed autofill to do that legwork for us. Pretty good. So it's nice to see that we have some auditing tools that allow us to evaluate functions and formulas to ensure that they're all working properly. And when they're not, these tools vastly come in handy when it comes to making sure that we know where and how to fix these tools when the time comes. Go ahead and take this opportunity to catch up. Once again, verify that your if functions are all answering the question properly. If they're not, use the formula auditing tools, both trace precedence and the show formulas tool, in order to evaluate whether or not they're referencing the appropriate cells. Pause the video and join me after the break. Welcome back. So we've asked our first question. Was the goal met? And with a little bit of work, we got Excel to answer that question for us. Now what do we want it to do? Well, we probably want it to calculate the bonus status. Let's say, for example, that if they hit their bonus, they get a 2% commission on top of their regular paycheck. Now, if I just go into the cell right here and calculate 2%, let's say I do that in cell I5, I'll just do equals the total times 2%. Okay, $725, I auto-filled down. Done, right? Except that only the people who hit the goal should get the bonus. So what am I going to do? Manually delete the cells that have bonuses where they shouldn't? Or can I let Excel do that for me? If you followed along, go ahead and clear out your bonus status column. Instead of just typing out the answer, we're instead going to give Excel the power to logically determine whether or not they should even calculate the bonus. Once again, we're going to start by inserting our if function. We saw that we were able to insert our if function using the Insert Functions tool, either here or here inside the Formulas tab. This time, let me show you another way. This time using one of the function library dropdowns. The function library dropdowns are simply books that contain specific functions. The if function would be considered a logical function, simply because we're asking a question. So by clicking on the logical dropdown, you'll see there's if. And I'm going to give it a click. So once again, we're going to answer the question, was the goal met? This time, however, instead of asking the question by calculating one cell greater than or equal to another, let's calculate by asking whether or not this cell says yes. Oops, what's going on here? Why did it give me an error? Well, remember what I said. When you're putting text into a function, you've got to remember to put quotes around the text. Otherwise, Excel is going to try and read that as a function. And there is no yes function. So H5 must equal yes. And check it out, it's true. H5 does in fact say yes. Now what do we want Excel to do if the value is true? Last time we just had it say yes, but in this case, instead of having it say yes, how about we have it calculate the bonus for us? In this instance, the total cell multiplied by 2%, the same function we used before. We'll tab down. And what do we want the cell to say if false? How about a big fat goose egg? In this case here, we're pretty much done, but we do want to verify. Does H5 say yes? Yes, it does. So if it's true, it should calculate the total times 2%, which comes out to $724.90. Meaning that because H5 does say yes, I should have a formula result that says, boom, $724.90. Now that we've verified, let's click OK to lock it in. And there you go. We can now autofill this down And in theory, it should cross-reference to see whether or not the cell says yes. If it does, it should calculate the bonus. If it does not, we should see 0 next to not a chance. So I'm going to go ahead and autofill down, and moment of truth. All right, there it is. So wherever it says not a chance, the bonus is 0. However, let's say S. Sandberg here picks it up, sells 8,801. Boom. Instantly calculates a bonus. Not a chance changes to yes, bonus gets calculated. Pretty cool. By automating this process, all we have to focus on now is inputting the data where it's asking for it. Go ahead and pause the video to catch up with me here. All right, we have got one box left. How hard could this be? The department bonus of $850 per person. All right, cool. So some of these people still have a chance. The department as a whole must have total sales of at least $200,000 and average sales of $9,000 or more per week. Okay, so we've calculated total sales and average sales. Now, sadly, I can already see they didn't quite meet it. But again, we don't necessarily want to be the ones to make this call, because as these numbers update, do you really want to be the one that's calculating all this, or would you much rather automate the process and allow Excel to tell you? Personally, I'll always go for the latter. This leaves me time to focus on the more important nuances of my job, like deciding what I'm going to have for lunch. Go ahead and place your cursor in cell I-12. One last time, we're going to start with our if function. I'm going to go ahead and use my function libraries dropdown. Of course, remember, you can always use the insert functions tool as well. All right, I'm in my if function arguments box. And the question is, does the department as a whole have total sales of at least $200,000? Okay, so logical test is total sales greater than or equal to 200,000? And the answer is yes. Okay, cool. But now where do I put the second part? Because it requires both. The condition is, in order to get the bonus, they have to have total sales of at least $200,000 and an average of $9,000 or more per week. So where do I ask Excel the second question? Well, this is the problem with if functions. They only allow for one logical test. So we need a function that allows for multiple logical tests. Fortunately, as it so happens, I happen to know of one function that does allow for logical tests more than one. It's called the AND function. So let's go ahead and type out our AND function here in the logical test box. Go ahead and type AND and an open parentheses. This open parentheses is key. In order to build another function within a function, go ahead and start typing that AND and that open parentheses. You'll notice in the formula bar, it's built exactly that for you, already with the closing parentheses. Once you've typed that AND open parentheses, you might be a little disappointed at this stage because you might have gotten attached to this function arguments box. At this stage, it doesn't look like we have access to it. However, it's important to note that you can only see one function arguments box at a time. In order for Excel to know which function argument box you need to see, you need to tell it. And the only way that we can really tell it is by clicking on it in the formula bar. So if you want to see the AND function arguments box, you have to click on the word AND. So go ahead and find AND in the formula bar and give it a click. Instantly, it drops you into the AND function arguments box. Once you've clicked on AND, make sure to click back inside the function arguments box. This is incredibly important. And there you go. So now we have room for two logical arguments. Let's try this again. The first logical test we know is total sales must be greater than or equal to 200,000. Okay, cool. We see that one's true. The second logical argument is average sales must be greater than or equal to 9,000. And sadly, they did not get that. But regardless, I don't seem to have access to a value of true or value of false. In fact, all I have is another logical arguments box. Fun fact, you can have up to 255 logical arguments inside of an AND function. Hopefully that's enough for you. But where's my value of true and value of false? Well, as it turns out, AND functions can't control value of true and value of false. That's a major limitation of AND functions. Now, if AND functions can have multiple logical arguments but can't control the output, and if functions can only have one logical argument but can control the output, maybe we can combine them and using the limitations of both to circumvent and make them strengths. So now that we've built our AND function, let's go back to our if function. How do we get back into our if function? Well, remember, we can only be inside one function arguments box at a time. And the only way to tell Excel to get back to another function arguments box is to find it in the formula bar and click it. So find if inside the formula bar and click on it. Boom! And we are back inside the function arguments box. And on top of that, because both conditions weren't met, the AND output is a false response. The only time AND will ever say true is if all conditions are met. Now what's our value of true going to be? Now that we've got a false response, we see here that it's not going to be a value of true, but we want to account for it if the data ever does meet the criteria. In this case, the value of true will be bonus in all caps. What's our value of false going to be? It can be whatever you want. In this instance here, I think an appropriate response would be sad face. So now that we've got our logical test, which is in and of itself another function, we've got our value of true and our value if false, let's go ahead and lock it in by clicking OK. And there you go. The department bonus is not achieved because unfortunately they didn't meet both conditions. However, let's say, just hypothetically, Elon Musk picks it up and sells $10,000 in week 1, bringing the average sales above $9,000, and check it out. Instantly, the bonus appears because the average sales spiked over $9,000. Not bad. Because we automated this entire process now, we can use this every single month. And it will always give us the right answers because we built the functions to logically reason with the data for us. Go ahead and pause the video and take this opportunity to catch up with us. Let's all take a moment, however, to click on cell I-12 and appreciate this function right here. You just built a nested function, a function within a function. This is just the beginning, but hopefully you saw how easy it was using that function arguments box to build all of this function within one. Go ahead and pause the video to catch up with me here. Welcome back. So hopefully you feel a lot more comfortable building if functions now, and hopefully you feel even more comfortable nesting those functions now that we have access to the function arguments tool. We're going to shift gears a little bit here and talk about a crowd favorite, VLOOKUP. Now, VLOOKUP is one of the most sought after skills when it comes to Excel database management. However, many people don't take the time to learn VLOOKUP because it feels scary, complex, overwhelming even. VLOOKUP is all about using a single search value to search an entire database and output a particular value. It stands for vertical lookup. In this example here, we're searching for employee ID. When we find the employee ID, what we'd like to do is find the output for last name, first name, department, and pay rate. To do that, VLOOKUP identifies a value, and then we tell it how many columns to the right of that value the output is. So let's get started. Go ahead and place your cursor in cell B4. Just like in previous instances, we could start by just typing an equal sign and then VLOOKUP. However, again, that's the long way. Instead, what I'd like to do is insert functions once again. This time I'll go through the process of selecting Insert Function, once again from the Formulas tab, or you can use the FX button here on the left of the formula bar. Using either one, you'll pop up here. Go ahead and search for VLOOKUP, all one word, and click Go on the right-hand side. Instantly, VLOOKUP bubbles up to the top and we get our definition. VLOOKUP looks for a value in the leftmost column of a table and then returns a value in the same row from a column you specify. Interesting. So let's take a look at that first line there. Looks for a value in the leftmost column of a table. This means that whatever value you're searching for must be the furthest column to the left. It can't search anything to the left of that. So that's a really important limitation to keep in mind. In fact, many people consider it to be the limitation when it comes to VLOOKUP. So let's go ahead and find the VLOOKUP option and click OK. And here you go. We're now inside the VLOOKUP function arguments box. The first thing it's asking for is the lookup value. Again, if you're not sure what that is, simply place your cursor inside of it and you'll get a breakdown. The lookup value is the value to be found in the first column of the table. In this case here, our lookup value is employee ID. This is the field that we have that we like to use to find last name, first name, department, and pay rate. So we're going to give it a click. And because this is the only cell, we're going to go ahead and absolute reference it just for good measure. Remember, we absolute reference by tapping the F4 key. The next thing it's asking for is the table array. Not sure what the table array is? Boom, right here. Table array is the table of text, numbers, or logical values in which data is retrieved. This is where we're searching for not only the value we're looking for, but the outputs we want. So essentially, that's all of this. So go ahead and inside the table array, now go ahead and click on cell A9. Now I'm going to show you a quick and easy way to select the rest of the data without having to click and drag, because we have no idea how many rows could be in here. By pressing and holding the Shift and Control keys, again, pressing and holding those down, tap the right arrow key once. You'll notice that now the flashing marquee encompasses everything from A9 to I9. I'm still holding the Shift and Control keys. I'm now going to tap the down arrow key. And check it out. It's brought me down all the way to row 46. Pretty cool, right? Once you've selected all that data, go ahead and tap the Tab key. So our table array is A9 through I46. In fact, we should probably absolute reference this as well, because that's not changing either. To absolute reference it, highlight everything inside the table array and tap the F4 key. You should have $4 total inside the table array field. Only 2 more fields to go, the column index number. This is the number in the table array from which the match and value should be returned. In this case here, how many columns from the left is the last name column? So if employee ID is column 1, then last name must be column 2. Remember, the search column does count as a column still. So the column index number is going to be 2, 2 columns from the left of the edge of the data. The last thing it's asking for is the range lookup. Now the range lookup is really important because it essentially determines whether you're going to get a relative match or an exact match. So let's say we're searching for an employee ID number that doesn't exist. Accidentally, we type in 1055 instead of 1054 or 1056. What would you rather have? An error that says that employee number doesn't exist? Or Excel guessing what it thinks you meant? When it comes to database functionality, you never want Excel to guess. If you're searching for something that doesn't exist, you always want it to tell you, hey, that's not there. For those instances, and really for almost all instances, the range lookup will be false, indicating that we want an exact match. Now you can type false, or you can use its binary equivalent of 0. So let's recap here. The lookup value is cell A4. That's where that cell is right there, meaning whatever number is inside there, that's what it's searching for. The table array is where our search field is and our answer field. In this case here, our search field is column A, all the way to column I. That's where our last output is. And we've absolute referenced both instances because no matter what, it should always reference the lookup value in that same spot and the table array in this same spot. Before we even click OK, our formula result tells us the response will be Smith. Let's double check. Employee ID 1054, let's find it. 1054, last name is Smith. So our VLOOKUP function is working. Let's click OK to lock it in. Not bad. Go ahead and pause the video to catch up with me here. Remember, we inserted the VLOOKUP function by using the Insert Function Arguments box. Simply click on Insert Function, search for VLOOKUP, and you're going to get this box right here. Our lookup value was the value we're searching with. Our table array was the data in which we are searching and in which contains the answer. Our column index number was how many columns from the left is the column output that we're looking for. In this case, the last name column was 2 columns to the left. From the left. And lastly, range lookup. Do you want a relative or an exact match? If it doesn't match, you want an error. So our range lookup is false or 0. Click OK to lock it in. Go ahead and pause the video. I'll meet you after the break. Now that we've built that function once, we probably really don't want to go through that process again. Fortunately, we had the foresight to absolute reference our lookup field and our table reference. So we can actually just autofill over to the right. Except it doesn't do exactly what we hoped it would do. Remember, we can always use our formula auditing tools to see what went wrong. But in this case here, I see that the column value simply didn't change. In order to fix that, I'm simply going to go in and change the value myself. Simply click on the first name field, and I'd like to jump inside my function argument box again. So select cell C4 and click on that FX button. This will bring you back into the VLOOKUP function arguments box. I see here that the column index number is still 2. However, the last name column is not 2 from the left. How many is it? 1, 2. It's 3 columns from the left this time. So 2 should actually be 3. And I'll go ahead and click OK. There we go. Let's do the same for department. How many columns from the left is department? 1, 2, 3, okay, 4. 4 columns from the left. Last one, pay rate. Once again, gonna click on the cell, hit the FX button. How many columns from the left is pay rate? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 becomes 9. Click OK to lock it in. Boom. There you go. So now let's test our work and see how it goes. So 1054, let's try 1152. And check it out. Everything updates appropriately. Mark Henders is 1152. What about 1310? Boom. All right. Let's try an employee ID that doesn't exist to ensure that it's not going to give us anything we didn't expect. Let's try 1059. And we see here, there is no employee 1059. We get these NA errors. Pretty good. Now, one thing that we should keep in mind here is that this database isn't going to be just for us. In most cases, we're going to be building this to hand off to somebody who doesn't necessarily have the same skills that you do when it comes to working with an Excel. One particular problem with that is these errors. When an error outputs, we know that this is because this doesn't exist. But you know who doesn't know that? Pretty much anyone who's not taking this class right now. All they see is an error, and to them, that error means that whatever you built is wrong, and they're going to come and find you. So instead of having to deal with all these people coming back and saying, hey, your thing is broken, let's soften the blow and change this error alert to something a bit more user-friendly. How do we do that? Well, we can use another function out there called ifError. If you'll remember, if functions allow us to ask a question to Excel, and depending on that response, control the output, either with a value of true or value of false. If errors work in a very similar way, but instead of giving you a value of true or value if false, it gives you a value if error, indicating that if an error occurs with a function that's already been built, you can control the output. So instead of getting this $NA, you could have it say something like unavailable. Now, I don't want to have to go and rebuild this function here. So instead, what I'm going to do here is, by clicking on cell B4, I'm going to navigate up to the formula bar and place my cursor between the equal sign and VLOOKUP. With my cursor there, I'm going to go ahead and type ifError and an open parentheses. Once I've typed ifError and an open parentheses, I'm now going to move my cursor to the middle of ifError, and I'm going to click on my function arguments box. Remember, cursor placement is incredibly important when using the insert function box. And check it out. We're now inside the ifError function box. Now you're seeing that you don't even need to build a function with the function arguments box in order to gain access to it later. So I've got my value, the value simply being the original function. However, if that value outputs an error, I have the value if error box. So what do I want it to say? Maybe I'd like my value if error box to say unavailable, or employee doesn't exist. Remember, put those quotations around when you're typing text. So go ahead and type in a value of error, and let's click OK to lock it in. And there we go. So now instead of showing me that ugly $NA sign, I'm getting no employee exists. Now, I could replicate this here, here, and here, or in these remaining cells, I could build an ifError function. Once again, by clicking between the VLOOKUP and the equal sign, typing that open parentheses and opening the function arguments box, I could have it give me a blank cell for the remaining three. To get a blank cell, simply type quotes twice. The double quote equals a blank cell. And go ahead and click OK. Go ahead and pause the video and take this opportunity to catch up. Build an ifError wrapper around last name and give it an output response. Then build an ifError function around first name, department, and pay rate, giving it a blank cell value. Once you've done that, unpause the video and come back for the next part. There you go. So now we have a fully functional VLOOKUP database. So if I search for an employee that does exist, like 1302, I get Randy Smith. However, if I search for an employee that doesn't exist, like 1055, I get no employee exists and a fully blank 3 additional cells. Not bad. So we're starting to see that VLOOKUP has a lot of power behind it. And in tandem with ifError, we can build a really nice looking database. Now there's one part when we were building the VLOOKUP function that we talked about, and it was the very last part. The range lookup. We talked about how in most instances we're going to want an exact match, because we don't necessarily want Excel guessing. The question often arises, when would I use true? When would I want a relative match? To answer that question, we have a bonus calculation table. Each of our employees here, Mickey, Donald, Bugs, people you may know, have their sales here, and what we'd like to do is calculate their bonus. Now, using VLOOKUP, let's try that out. I'm going to go ahead and build out a VLOOKUP function, starting here in cell C4. By clicking on the Formulas tab, I'm going to go ahead and jump into the Insert Function Arguments box. Fortunately, because VLOOKUP was the most recent function I used, it's up here at the top, and I can just click that and select OK. Of course, for you, if it's not, you can always use the search function to find it as well. So what's our lookup value? Well, our lookup value in this instance is going to be here, Mickey's sales. The next thing it's going to be looking for is the table array. Where is the data that we want output? And in that instance, that's going to be here. Now, because the table array is never going to change, and in most instances won't, it's a really good habit to be in to absolute reference the table array. The next thing it's asking for is the column index number. Now, in this instance right here, I'd like it to just tell me the bonus. So the column index is going to be 1, 2 cells to the right. So my column index number will be 2. Now remember, we talked about using range lookup, how in most instances we don't want a relative match, we want an exact match. So I'm going to type 0, and I'm going to click OK. And you'll see that I get an error message. The reason being is that 1200 doesn't exist inside the sales table. Instead, the way this bonus table is set up, it's when they exceed a certain value, they qualify for a bonus. So Mickey, because Mickey sold $1,200 in sales, should have qualified for a $10 bonus. However, I'm only getting an NA error because it was looking for an exact match. So let's fix that. Click on cell C4, and let's jump back into that Insert Arguments box. This time, instead of asking for an exact match using the absolute search, I'm going to look for a relative match by changing the range lookup from 0 to 1, indicating a true response. And I'm going to click OK. There you go. So now we see that Mickey gets a bonus of $10 because Mickey sold more than 1,000, but not more than 1,500. It's important to note that the relative reference will only find values that it's already exceeded. And in these instances, it's incredibly important to remember that when using relative range lookups, this table, the column that you're searching in, must be in ascending order. I'll say that again. When using relative range lookup, you absolutely must ensure that the column you are searching inside is sorted in ascending order. Ranges don't work well without that order sort. Now that we've built this function out, because we absolute referenced the table field, we can now autofill down, and boom, there we go. Donald sold $1,300 and therefore also gets a $10 bonus. Bugs sold $2,500 and therefore gets a $125 bonus. Daffy sold $850. Notice that because Daffy did not exceed 1,000, gets a $0 bonus. So now you're starting to see that there's a real-world use case for using range lookups that are not absolute. Now, let's take a look here. We see that there's also a third column for holiday bonuses. Maybe we'd like to handle that. Now, before we jump into that, go ahead and take this opportunity to pause the video and catch up with me here. You should have a bonus that directly correlates with the bonus column here. Go ahead and pause the video and catch up with me. Welcome back. Before we went on pause, we referenced that there's a third column that we don't seem to be able to search just yet. However, we do have the ability to build that functionality in. Is this a standard or a holiday bonus? Well, by clicking in that gray cell, you'll see that somebody, I won't name names, injected data validation. So now I can click on the dropdown and determine whether this is a standard or a holiday. Let's go ahead and click holiday and see what happens. Nothing. Yet. Because we haven't done anything with it yet. However, how could we get Excel to, in one situation, do one thing, and in another situation, do another? Well, how can we ask Excel a question? Somebody out there is screaming at the top of their lungs, if function, if function. And that person is right. We can use an if function to build out a if this says holiday, calculate the holiday bonus. And if it does not say holiday, calculate the standard bonus. So let's go ahead and do that. Just like what we did with the if-error function, we can build an if wrapper around the existing function. However, for the purposes of this class, we're going to keep things simple. Instead, go ahead and highlight the function that's already been built and delete it. We'll only do this for Mickey, and we'll carry it on for the rest. We're now going to go ahead and insert our if function from the logical function arguments box. Go ahead and find if from the logical function library and give it a click. So what's our logical test? If this cell equals holiday, then what? Well, in both instances, we want it to calculate a VLOOKUP output response. However, each of those will be slightly different. One VLOOKUP will look in the bonus column, and the other will look in the holiday column. So in this case, if it's true, that means that this cell says holiday, meaning that we should build a VLOOKUP function that outputs the holiday bonus. So let's go ahead and start by typing VLOOKUP, open parentheses. Remember that open parentheses is critical. Once we've typed that open parentheses, we need to open up the VLOOKUP function arguments box within this if function. So let's go ahead and find VLOOKUP in the formula bar and click on it. We're now inside the VLOOKUP function arguments box. So what's our lookup value? Well, it's still the sales. And the table array is still everything here. Remember to absolute reference your table array. And now our column index number. In this instance, we're trying to determine the value if true, meaning that we want to pull if true, that means that this says holiday and they should be getting the holiday bonus, meaning the column output should be 1, 2, 3. It's the third column from the left. Lastly, do we want a relative or an exact match? In this case, we want to allow for a relative match, so the range lookup will be either true or its binary equivalent of 1. Now don't click OK yet, because we're not done. It's really easy to forget that we're still inside the if function. In fact, that's probably the most dangerous part about the function arguments box, forgetting that you're still inside an if function, or any function for that matter. Once you're done building your VLOOKUP function, go ahead and jump back into the if function arguments box by taking your cursor again to the formula bar and clicking on if. And there you go. So we've got our logical test. If C12 says holiday, calculate the value of true, VLOOKUP, and the output is the holiday column. However, if the value is false, we still want it to calculate a VLOOKUP, but instead of pulling from the holiday column, we want it to pull from the standard bonus column. Now I really don't want to have to go and rebuild that VLOOKUP function. Fortunately, this function is almost identical to the one that we're going to build anyways. So go ahead and highlight that value of true, and using the keyboard shortcut of Control-C, or from the Home tab clicking the Copy button, go ahead and drop down into value if false and paste it. The only thing we have to change is the column output. You can change the column output by simply identifying that number 3 and changing it to the output of the column for the standard bonus. In this case, column 2. So we've got our logical test. If C12 says holiday, calculate the VLOOKUP with the holiday output. If this cell does not say holiday, calculate VLOOKUP with the output of this column, the standard bonus. Let's click OK and make sure everything works. And there it is. I'm now going to go ahead and autofill this function all the way down to ensure that everybody has the same if function built. But it doesn't seem to have done anything. Huh. What do you think went wrong? Someone out there, probably that same person that shouted if function earlier, is shouting, "You didn't absolute reference C12." Meaning that while this one cell is double checking to see if C12 says holiday, every other cell is checking C13, C14, 15, and so on. And those cells don't say holiday, meaning they're still getting the standard bonus. So let's fix that. By clicking on the function that we built already in cell C4, we're going to simply place our cursor on top of C12 and absolute reference it using the F4 key. Having done that, we're going to go ahead and tap Enter to lock it in. And now, finally, absolute reference it for the final time and autofill down. And there you go. Just like that, everybody gets the holiday bonus. But if I click and I change the holiday dropdown to standard, everyone gets a standard bonus. So there you go. By building this if function, we now have a fully automated bonus calculation table that, depending on whether or not it's a holiday or a standard payday, they get a bonus relative based on that content. We don't have to do the math anymore. With VLOOKUP and that relative range lookup, all we have to do is input the sales and tell it whether it's a standard or holiday bonus. Go ahead and pause the video and take this opportunity to catch up. It's time to talk about the red-headed stepchild of the lookup family, HLOOKUP. HLOOKUP is one of the most underutilized functions, but it is important to acknowledge that it does exist. HLOOKUP is the polar opposite of VLOOKUP. Instead of using the vertical search in order to output a value, it uses a horizontal search to find the individual row outputs. In this instance, we're searching for a specific product code, and we're trying to find the output in particular warehouses around the globe. In this case here, the product code is here, on the top row, meaning that we're going to be searching horizontally, and from here, finding the row output from the top. Let's go ahead and build it out. Placing your cursor here in cell B6, we're going to go ahead and insert our function arguments box by finding the FX button here or in the Formulas tab. Either way, go ahead and search for HLOOKUP, all one word once again. Once you find it, go ahead and click OK. It looks almost identical because it is identical. It's the same function, simply searching from a different direction. In this case, our lookup value will be here, B5. And because we have the foresight to know we're probably going to autofill this down, let's do ourselves a favor and absolute reference it now. The next thing it's looking for is the table array. Where is it going to be searching for XP200? And on top of that, where is it going to be searching for the outputs for warehouse 1, 2, and 3? It's going to be searching here, from A11 to G14. We're going to need to absolute reference that one as well because remember, always absolute reference the table array. You never know if you're going to be autofilling, so hedge your bets. The next thing it's looking for, our row index number, which, just like our column index number, only starting from the top this time. For this first one, warehouse 1, how many rows from the top is warehouse 1. In this case here, the first row of values we're searching is row 1. So warehouse 1 is row index number 2. Lastly, do we want an exact or a relative match? Well, this time we're talking about database functionality, so we don't want a relative match. We don't need Excel guessing. So our range lookup will be false, or its binary equivalent of 0. Having built that all in, go ahead and click OK to lock it in. And there you go. Now that we've built that out, we can autofill down and adjust the row value number as necessary. In warehouse 2, how many rows down is the warehouse 2? 1, 2, 3. So either by opening the function arguments box and changing the row index number here, or by changing it in the formula bar up here at the top, go ahead and make changes to warehouse 2 and 3 to ensure that they're outputting the appropriate value. The last one for warehouse 3, how many rows down is it? 1, 2, 3, 4 rows down. So 2 becomes 4, and there you go. So there you have it, HLOOKUP, just like VLOOKUP, only the other way. Go ahead and take this opportunity to pause the video and try this out for yourself. Keeping on the trend of database functionality, let's talk about some other really useful database functions. VLOOKUP is great, but it only gives us a single output value. If we're trying to organize a lot of output values into a single response, VLOOKUP isn't quite what we want it to be. In this instance right here, let's say we're trying to calculate the total expenses of particular categories. In those instances, what we'd like to do is search for a particular category in this column, and once identified, take the total expenses and sum them up and output here in the total expense field. VLOOKUP can't do that for us. However, there is a database function that can. Now, this is a conditional statement. If this cell says something, then we should find the total expenses that correlate with it and sum them up. Sum and if. This is the SUMIF function we're talking about here. Go ahead and place your cursor here in cell J14 with me. And we're going to go ahead and insert our SUMIF function. We can insert our SUMIF function from either the Insert Function Arguments box and searching for SUMIF, or you can always use the Math and Trig function library and find SUMIF here. Now it's important to note that there is a SUMIFS as well. Please don't mistake the two. There is a difference and we'll talk about it. But for now, simply find SUMIF, either using Insert Function Search or the Function Library dropdown. And here we are. Now the first thing it's asking for is the range. Now the range is the field of cells that you want evaluated. In this particular instance, where are we searching to find software? Now I could go here and just click and drag everything, but that's tedious. So let's not do that. Go ahead and close out your function arguments box if you have it open, and let's help ourselves out here ahead of time. Go ahead and place your cursor anywhere inside the dataset, and tap Ctrl-A to select the entire dataset. If you feel more comfortable clicking and dragging, you're more than welcome. Just simply ensure that you've highlighted everything from the headers down to the very bottom of the dataset. I promised you it was coming back. Let's go ahead and create some named ranges out of these. Now, we have headers, meaning we can use which of these, define name or create from selection. Well, as I hover over create from selection, you'll notice it says automatically generate names from the selected cells. In this case here, this is the tool we want. I'm going to click create from selection. And in this instance, it's a little confused. It doesn't know where my headers are. Am I pulling names from the left or from the top? I'm not pulling it from the left because that's just another column. I'm pulling my headers from the top row, so I'm going to deselect the left column and leave top row selected and click OK. I've now created categories: division, category, January, February, March, and total expenses, all derived from this highlighted data. Let's see if that makes a difference to us when we're building out our SUMIF. Once again, let's go ahead and open up our SUMIF function arguments box. I'm going to use the math and trig function library and find SUMIF. Once again, ensure that you are not using SUMIFs, but SUMIF. So once again, what's our range? Our range is where we are looking to find software. Which of these columns contains our search criteria? In this case here, we're searching for software in the category column. Now, instead of clicking and dragging to highlight all of that, I'm going to use the Use in Formula dropdown to select category. And check it out. On the right-hand side here, I see technical support, telephone, copying. Those are the first 3 entries in the category column, so I know that it's referencing the right data. Next, I'm looking for the search criteria. What am I looking for in the category column? In this case here, I'm searching for software in the category column. I want to find the word software. So I'm going to go ahead and click here. No matter what this cell says, I'd like Excel to search that word in the category column. So currently I'm finding software in the category column. Now, once I find software, what would I like to do? My sum range. This is the most important part here. Once I find each individual instance of software, which of these cells am I going to, from this row, sum together? In this case, I'd like to sum up the total expenses that correlate with software in the category column. My sum range, while I could click and drag from the top down for total expenses, I've also created a named range called total expenses. So just like that, my range is category. This is where I'm searching for my criteria, in this case, software. Once I find all instances of software, I'm going to sum up all of their correlated total expenses. Look how simple that is with named ranges. Isn't that something? Once you've got that up and running, go ahead and click OK. And there you go. So in software, we spent $17,215 in Q1. Now the cool part about SUMIF wasn't that we were able to pull that number out, although that is pretty cool in and of itself. It was that we told it to reference this cell. We didn't tell it to search for software. We told it to search for whatever word was in this cell. So I can change this word to any category, and the number should, in theory, change. So let's try rent. Tap enter, and check it out. The total expense field automatically updated. What about advertising? Spelling does count. Wow, $144,000. Go ahead and take this opportunity to pause the video and make sure your SUMIF function is working. Once again, the way we got there was by inserting a SUMIF function, either from the insert function arguments box or from the math and trig dropdown towards the bottom. Once we did that, we implemented named ranges to determine the category, which is where we were searching for the criteria. Our criteria is what we were searching for, and our sum range was what we wanted added together when we found our fields. Go ahead and pause the video and take this opportunity to try this for yourself. All right, now that we've tried that once, let's try it with another one. This time, we're looking for the average expenses of a particular category. So we're not going to be using SUMIF this time, but we are still asking an if question. We're just not summing. So what function is out there, or might be out there, that instead of summing based on an if, averages based on an if. Please don't make me spell it out any more than that. We're looking for the average if function. Now, the average if function can be found from the insert functions box or from more functions, statistical average if. Once again, there is an average ifs. However, we'll be talking about that one just a little bit. Go ahead and find average if and give it a click. It looks identical to the SUMIF function because it is. The only difference is the mathematical calculation that takes place within the range field. So in this case here, our range. Once again, where are we searching to find our criteria? Our criteria is the category rent. So where are we searching for the word rent? Well, in the category column. We could click and drag to select the category fields, but this is tedious. Instead of doing that, because we created a named range, all we have to do is click that Use in Formula dropdown here in the Formulas tab and select Category. Once again, verify that on the right-hand side you should see the first 3 instances of the category column: technical support, telephone, and copying. Our criteria, or the cell that we're using to determine what we're searching for, is here, in cell I-20. So whatever this cell says right here, we're going to be searching for in the category column. Lastly, what field are we averaging together once we find all instances of rent? We're going to go ahead and use total expenses once again. So go ahead and click on that Use in Formula dropdown and find total expenses. Once again, verifying that these instances match the column: 2,150, 2,150, 26, 26, good. Hopefully you're starting to see here that named ranges can really pay off when it comes to building out database functionality. Once you've got everything where you want it, go ahead and click OK. And there you go. It's just that easy. So the average expense for rent is $17,790. I can now change this to something like overhead to see what the average there is. In this case, $3,700, or maybe telephone, $2,400. Pretty cool. So it's searching for all available instances in the category column and giving us the total and average expenses. I could even link this cell using linking data, which we learned about in a previous lesson, to reference this cell, meaning that whatever I type inside this cell right here will reflect in both. So if I type rent, I can get the total expense and the average expense instantly. Pretty cool, huh? Go ahead and pause the video and take this opportunity to try that for yourself, and then come back for the last part. All right, welcome back. So we've got one last box to search in. We're trying to find total expenses for category, but this time not just the category, but a specific division category. So in this example here, SUMIF isn't going to cut it. SUMIF only allows for one search criteria. Instead, we're going to need to turn to a SUM function that allows for multiple ifs. Oh, come on. I know you know where I'm going with this. Yes, we're talking about SUMIFs. So using either the insert functions argument box or the math and trig dropdown, we're going to find SUMIFs with an S at the end, indicating multiple conditions. And here we are, back again. This time, instead of starting with the range, it's starting with the sum range, which is the number of fields we want added together. In this case here, it's going to be total expenses once again. So I'm going to click on my Use in Formula dropdown, select total expenses, the named range that I created earlier, and now I can focus on the next field. In this case here, criteria range 1. Well, what's my first range going to be? In this case, we'll say that the first range is going to be division. We're going to be searching inside the division column to find the word east. As with all of these, I could click and drag to select that entire column, but instead, I'm going to use that named range I created. In this case, the division named range. And I can see here, east, 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 east. Yep, that all lines up. So I'm searching inside the division column for what? Well, I'm searching for the word east, here in cell I8. So whatever I8 says, that's the division I'm searching for. The next thing it's asking for is criteria range 2. Okay, so we're on the next field. In this case, we're searching for category. So we're going to need to find the category named range. Total expenses is the sum range. Criteria range 1, we're searching for division. We're searching for east in the division column. We're searching in category for the second range. And we're searching for software in cell J8. And there you go. Now, of course, you can allow for multiple criterias. You can actually have up to 127 different criterias. In this case here, however, we only need 2. So, having done all that, let's go ahead and click OK to lock it in. And there you go. So in the East Division category of software, they spent $5,875. Meanwhile, in the North Division for the same category, they spent less, $3,805. What about the North Division in contractors? $3,750. What about the West? Is there a West? There is a West, and they spent the same amount. Convenient. What about the South? Wow, the South spent a lot on contractors. So it's interesting to see how we can pull this information out. I might want to look into this if this was my company. And there you go. So ifs, sum ifs, average ifs allow for multiple conditions. However, all of these functions, sum, average, count even, allow for us to build out database functionality that, based on certain conditions, pulls out a predetermined cell and sums, averages, or counts it up. Go ahead and take this opportunity to pause the video and try this for yourself. It's pretty cool. Welcome back. Time for a bit of a brain break. Let's talk about working with dates inside of Microsoft Excel. Dates aren't that hard to work with. In fact, there's a misinterpretation that because they're dates, they can't be manipulated the same way regular numbers can. That's not the case at all. Let's go ahead and start with something simple. Now, I'm going to go ahead and insert today's date. In this case, the day I'm creating this video is November 24th, 2015. But instead of typing that, I can let Excel do that because surely it knows, right? I can use the keyboard shortcut Control semicolon to insert today's date. Go ahead and try that for yourself. Once again, pressing and holding the Control key and tapping the semicolon key. Now, we fell into a coma a couple of days ago, or weeks ago, and we let a couple of bills slip past. Maybe we took a really long nap. Let's say that. Now we need to calculate how many days overdue we are so we can prioritize which bills are the most overdue and pay those first. Now how do I calculate that? How do I take the due date and find out how many days overdue any one particular bill is? Well, how would I calculate the difference in any other number? Let's say I had a number 15 and a number 11. If I wanted to calculate what the difference was between 11 and 15, how would I do that? Well, I would subtract 11 from 15. So why can't I do the same thing with dates? Well, really, you can. In Excel, they actually figured out a way to take two dates and subtract them. Just like with any function, we're going to go ahead and start with an equal sign. And we're going to take today's date, in this case, cell C1, and subtract it from the bill's due date, B5. Now, I have the foresight here to see that I'm probably going to autofill this down, so I'm going to go ahead and absolute reference that C1, meaning that I always want C1 to be the reference field. However, I do want B5 to become B6, B7, and so on. Once you've got this function up and running, go ahead and tap the Enter key, and there you go. So this bill is 10 days overdue. Now that I've built that, I'm just going to go ahead and autofill down. Woof. Those poor guys at Comcast, they're hurting for that bill. Now, with that having been said, how does it know? How does it take a date and add and subtract it? Well, Microsoft had to figure out a way to turn dates into numbers. Go ahead and highlight all of the bill due dates here, and from the Home tab, find the number command group, and let's change the number formatting from custom to general. Many of you have seen this before, but probably by accident. What do these numbers mean? How could this possibly be a date? Well, it actually is. Microsoft had to figure out a way to convert dates into numbers that could be added and subtracted. So these are actually the number of days since January 1st, 1900. In this case here, this date right here is 42,322 days past January 1st, 1900. The same thing works for today's date. If I change the number formatting from custom to general, I see 42,332. So what's 42,332 minus 42,322? Well, it's 10. And that is how Microsoft figured out how to add, subtract, multiply, and divide dates. Let's try another one. Let's play the How Old Are You game. In this case, let's go ahead and start by typing our birthdays. In this case, my birthday, September 11th. I don't know if I should give you guys the year. We'll say 1980. So September 11th, 1980. And from here, now I'd like to calculate how many days it's been since birth. So how do I do that? How do I calculate how many days between this day and, let's turn that back into a date, this day? Well, the same way we calculated how many days past due these bills were. By subtracting. So once again, I'm going to start with my equal sign, and I'm going to take today's date and subtract the birth date, and tap Enter. So it's been 12,857 days since my quote-unquote birthday. This is the actual birthday. This is not my birth year. Now, how do I turn that into an actual age? Well, how many days are in a year? Well, there's 365 days in a year, but there's also leap years to take into account every 4 years. So how do I take that into account? Well, I'm going to go ahead and start with my equal sign, and I'm going to take the days since birth divided by, let's see, there's 365 days in a year. Every 4 years there's a leap year, meaning that we're going to divide it by 365.25, meaning that for every 4 times we divide into it, that accounts for an extra additional value. This should account for leap years. And from here, I'll go ahead and tap the Enter key. So according to this, I would be 35 years old. There you go. It's that easy. Working with dates in Excel doesn't have to be hard, and in fact, knowing how they work makes things that much easier. Go ahead and take this opportunity to try this out for yourself, and then join me after the break. Welcome back. So we're looking at names. Here on the left-hand side, we've got a last name column and a first name column. Now, we started doing this Interestingly enough, because of form letters. You know those form letters? Those letters you get that tell you your credit has been approved for a $10,000 gift card? Hooray! Well, we started separating first name and last name because of those form letters. However, we're starting to get smarter at that, and so we don't necessarily need two separate columns. But all of our old databases still have them segmented. So how do we bring them back together? We can use a text-based function. In this case, the text-based function is called concatenate. It's okay, you'll be forgiven for not necessarily knowing how to spell that one. Fortunately, we have the Formulas tab, Text Function Library. So placing your cursor here in cell E5, go ahead and click on the text dropdown, and thankfully, mercifully, there's our concatenate tool. So go ahead and select concatenate, and that'll pop that box up. So in this case, our text1 box is going to be first name. Okay, I'm with you so far. What's our text2 box going to be? Last name. Cool. All right. But as I'm looking at this here, I see that the formula result is giving me Howard Smith as one word. But Howard Smith isn't a name. What should have happened? There should have been a space in between. We actually have to tell Excel to put a space in. It's a very literal program. So go ahead and delete text2. And how do we inject a space? With a quotation mark, a space bar, and another quotation mark, indicating one space. So once again, the way we did that was with a single set of quotes, a space, and another set of quotes. Lastly, for text 3, we'll go ahead and choose the last name once again. And now we see the formula result is now Howard Smith instead of Howard Smith. Once you've done that, go ahead and click OK. Fortunately, we don't have to build that any more than once. We can simply autofill down by clicking and dragging. Boom. And there you go, concatenate. Pretty cool, right? There are plenty of real-world uses for this. This is just one common example. Another fun text function is the left, mid, and right functions. Here in the middle, I've got nevertheless. Now, nevertheless has 3 separate words in it. Currently, they're all residing in cell I8. So let's say I'd like to segment them out into their individual parts. Here in cell H5, I'm going to go ahead and insert yet another text function, this time the left function. The left function simply allows us to pull a number of specified characters starting from the left side of a given cell. The text box here is asking what cell is the word in this case, I8. Now by default, it'll pull just one character. However, in this case, I'd like to pull 1, 2, 3, 4, 5 characters in order to pull the word never out. So I'm going to go ahead and type 5, and there you go. So by selecting cell I8 and saying I wanted 5 characters from the left using the left text function, I'm now going to hopefully get the word never in this box right here. Let's click OK to lock it in. There it is, never. Let's go ahead and try mid. Once again, I'm going to go ahead and find my text dropdown, and there's mid. The first thing it asks for, just like with the left function, is where is the text? Well, it's in cell I8 again. Now this time, it's got 2 fields after the text, a start number and then a number of characters. So the start number is the number of characters from the left you'd like to start before starting to collect a number of characters. Now in this case, the first character is number 1. So how many cells do you want to skip before you start collecting numbers? In this case, we'd like to skip never. So we want to start 1, 2, 3, 4, 5, 6. We want to start at character number 6. Okay. How many characters from character number 6 do we want to collect? Well, if we're pulling the word the out of the middle of this, we need 3 characters. So starting from 6, we want T, H, and E. And there you go. In the formula result, we see the. And we're going to go ahead and click OK. The last function, right. So if left pulled a certain segmented number of characters from the left, and mid pulled a certain segmented of characters from the middle, go ahead and take a wild guess where you think you're going with this right function here. Using the text function library dropdown, we're going to find right. Just like the left function, it asks for us to start with where is the text. We've got I8. The number of characters it's asking for from here. How many characters from the right is the word less? In this case, it's 4 characters from the right. And there you go. Go ahead and click OK to lock it in. And there you have it. Never the less. All pulled from one cell. Pretty cool. Go ahead and take this opportunity to try that out for yourself. Hello, and welcome back. We're going to get right into it. When we're talking about working inside of Excel, there's a lot of different things that can mean. It can mean we're going to be typing a bunch of stuff into a spreadsheet. It can mean that we're analyzing reports as they're coming out of a database. It can also mean taking lots of reports from lots of different places and consolidating them into one small spot. The benefit to this, of course, is that we don't have to manually do it ourselves if we know how to do it. In this particular instance, I'm looking at database outputs for my Connecticut division, my Maine division, my New Hampshire division, and between all 3 of those, they're all tabulating the same things: software, training, maintenance, and miscellaneous expenditures for quarters 1 through 4. What I'd like to do is take all of these reports from all of these different sources and consolidate them here into the all division summary. So let's go ahead and take this opportunity to do just that. The first thing we're going to need to do is start here from the summary page where we'd like the output to be. We're going to go ahead and highlight all of these empty fields from item down to the 0 at the bottom of quarter 4 totals. We're going to highlight all of this because we'd like to maintain this structure from all of the different outputs. Now that we've highlighted these empty fields, go ahead and find the Consolidate Data tool. This can be found inside the shocking Data tab on the far right-hand side with the word Consolidate. Find that Consolidate tool and give it a click. The first thing it's going to be asking for is what kind of function are we using? In this case, because we're consolidating all of these individual items into a single division summary, we're going to be summing. The next thing it's asking for is our first reference. We'll go ahead and start in Connecticut. Our first reference is going to include all of the heading items down to and including the quarter 4 totals. Once you've highlighted all of that, go ahead and click Add. And that will add Connecticut and all of those fields to the reference field. Let's go ahead and jump over to Maine for the next one. Conveniently, those dancing ants continue to remain exactly where we want them. So all I have to do now is click Add again. One last time, New Hampshire. Once again, everything is exactly where I need it to be. Of course, you want to double check that to be the case every single time. And we're going to go ahead and click Add. Having pulled from all 3 resources, in this case, Connecticut, Maine, and New Hampshire, all we've got to do now is determine where to use the labels from. And in this case, the labels exist in the top row as well as the left column, so both will be checkboxed. Once we've got everything up and running, verify that all references are in place, we're going to go ahead and click OK to lock this in. And just like that, everything has been consolidated into my all division summary from all 3 worksheets. We can verify by going to Connecticut, and let's say for quarter 1, software. Connecticut pulled 200. Maine, 400, that's 600 total, so New Hampshire must have 200, coming out to 800 total. Check it out. That's pretty cool. Go ahead and take this opportunity to try it out for yourself. Once again, the way we got here was starting by highlighting where we'd like the output to be. We then turned on the Consolidate tool. From here, we selected each individual reference and clicked Add for each of the 3 state divisions. From there, we told it which labels to use, in this case the top and left column, and then clicked OK. Go ahead and try that for yourself, and join me after the break. Welcome back. So now you've gotten a taste of consolidated data. Now that one worked really well, but it also had everything in the exact same order. So software was in the same place on every single sheet, and so was quarters 1 through 4. Let's talk about one where everything might not be exactly the same. Here I'm looking at consolidated sales data for Henry Albertson, Alan Patel, and Caroline Brenshaw. Now in each of these, they're selling different products in some instances, but even when they're selling the same product, it's not in the same place. So in this example here, we're not necessarily going to have the luxury of being able to highlight and select so that we can autofill it into some pre-formatted structures. Go ahead and place your cursor in cell A5 here. And we're going to go ahead and start with the Consolidate button once again. For reference, we're going to go ahead and start with Henry Albertson. Once again, we are going to include the headers. So in this case, the Albertson worksheet from cell A4 to C7. Once again, we're going to click Add. We'll go ahead and jump over to Alan Patel. Fortunately, the flashing marquee is exactly where we need it to be, and we can just click Add. Lastly, in this case for Caroline Brenshaw, there's a line missing here that wasn't missing for the other 2. So we're going to need to readjust the flashing marquee, and then click Add. Once we've got all 3 references in place, once again we need to verify where the labels are. In this case, the labels still continue to be on the top as well as on the left. So with that having been said, go ahead and click OK. And there you go. It's that easy. Now let's verify to make sure that it matched up everything with what it should have been. In this case, now we see there are 4 lines. Now in none of these were there 4 lines. So already that's a good sign. Let's take a look at Encyclopedia. Henry Albertson sold $34. Okay. Oh boy, 54. So 34 plus 54, we're talking about 88, meaning that should mean that Caroline didn't sell any encyclopedias because that's already $88. So I'm going to go ahead and jump over, and she did not. So that comes out to 88. And in fact, we can verify that with each individual item. It's actually verified each individual row value, identified it, and matched it up to give us our sales, summation, and commission. Go ahead and try that for yourself, and join me after the break. Welcome back. So, enough of the cupcake talk. Let's talk about something a little bit more substantial. In this case, transportation and shipping costs. Now, it's never too soon to prepare for the next holiday season. To optimize shipping costs, the following constraints must be put in place. Each of these plants must produce at least 20 units a quarter to justify remaining open. Charlotte has a maximum capacity of 92 units per quarter, Portland 45, and Quebec 55. Plant production must equal the requirements of the warehouse since there is a short shelf life. What is the lowest possible cost of shipping we can achieve? So once again, we're going to be turning to our solver tool to calculate this. In this case here, what's our objective? We're trying to calculate the lowest possible cost of shipping. So our objective cell is going to be the total cost once again. In this case, H7. Only now, instead of calculating the max, we'd like to calculate the minimum. The next thing it's asking for is, just like last time, what variable cells do we have? Well, in this case, we're actually going to be handing over all of this from B5 to E6. We're surrendering control of all of the product shipping. So B4 to E6 are the variable cells. With that in play, the next thing we need to do is simply implement the constraints. Because at this stage right here, the lowest possible option by changing these values is 0. So let's go ahead and add some constraints. Each plant must produce at least 20 units a quarter to justify remaining open. So something must be greater than or equal to 20. And in this case, this is specific to each plant in each quarter. So that's all the cells. B4 through E6 must be greater than or equal to 20. So that's our first cell reference. We're going to go ahead and lock that in by clicking Add. Charlotte has a maximum capacity of 92 units per quarter. So that's going to apply to everyone in Charlotte. Each of these cells, at a minimum, or at a maximum rather, must have at least 92 units. So Charlotte, in each quarter, must be less than or equal to 92. Portland must be less than or equal to 45. And Quebec, with a maximum capacity of 55 units, must be less than or equal to 55 per quarter. The last constraint, plant production must equal the requirements of the warehouse since there is a short shelf life. This means that on each quarter, these fields must equal these fields. So in quarter 1, we absolutely have to create 180 units. Meanwhile, in quarter 2, we absolutely can only increase to 80 units. 190 for quarter 3, and 160 for quarter 4. This is our last constraint. So instead of clicking Add, we're going to click OK. This time now we have 5 separate constraints. That's a good chunk of change right here. Now there's really nothing left to be said except, do we have our objective? Sure. Minimize the total shipping costs. Do we have variable cells? Yes. Control how much output in each plant per quarter. And do we have the constraints? Yes. We've implemented all of them. No plant must produce less than 20 units per quarter. Charlotte must produce at a maximum 92 units. Portland at a maximum must create 45. And Quebec at a maximum must create 55. Now each of these plants has its own shipping per unit cost. So now the only thing that's left for us to do is leave it to Excel to find out exactly how much we should produce where. Go ahead and click Solve. And just like that, it is calculated that the lowest total possible cost of shipping is $1,011. In almost all instances, it seems to have overloaded Charlotte. Now, logic might dictate that we would try to overload Portland, but Portland has only 45 units max. So naturally, Charlotte, being the second cheapest shipping option, maxed out in nearly every quarter except for quarter 2 because of limited warehouse capacity. Microsoft figured all of that out by just implementing these constraints. Pretty cool. To restore back to original values, simply check Restore Original Values and uncheck Return to Solver Parameter Dialog, which brings us back to square one. Go ahead and pause the video and take this opportunity to try this out for yourself. I'll meet you after the break. Welcome back. So now that we've seen that there are some tools available that allow us to kind of offload this decision-making process to Excel, especially when it comes to just something as simple as consolidating data, it makes you wonder, what else can Excel do for us? For this next part, I'd like to talk about a tool that's actually not readily available inside of Excel. It's a tool called the Solver tool. As we're looking at this first example, it says the client is paying per item. Oh, we're a bakery now. Cool. The client is paying per item. Calculate the highest total cost we could sell the treats for. And then we've got some constraints. Oh. All right, I'm getting a little bit of PTSD back to my SAT days. Something about a train leaving a station and blah, blah, blah. I really don't want to have to make any sort of effort on this. Right? How would you even go about solving this? We need 400 desserts, at least 50 of each dessert. You can't have more than 100. How do you solve this? I wouldn't want to go through this process. And frankly, you don't have to. Excel actually has a tool available that's designed to solve complex questions like this with specific limited parameters. However, in order to use it, we have to go install it first. Now don't worry, you don't have to leave Excel. It's relatively easy to find. Go ahead and dive in with me to the File tab. Inside the File tab, go ahead and jump into Options. Once we've jumped into Options, we're going to go ahead and need to find the Add-ins tab. Here. Here inside Add-ins, we're going to need to find the Manage Add-ins and click Go. And it's here that we'll see the Solver add-in here at the bottom. Go ahead and checkbox that. And once you've checked it, go ahead and click OK. It only takes about a second to download, and once it's done, you'll see it here on the far right-hand side of the Data tab, the Solver tool. So let's go ahead and turn it on. Now the Solver tool is an example of what we call what-if analysis, meaning that we can say what if it had all of these constraints and we were trying to find a specific output. The first thing we're going to need is to set an objective, meaning one cell that we'd like to control the output of. In this case, we're trying to control the total cost. We want to find the highest total cost we could sell the treats for. So our objective is going to be to set this cell right here to the highest possible option. So here, set the objective D8 to max. The next thing we're going to need to set are the variable cells. We're actually going to give control of some of these cells to Excel in order for it to determine what the best combination of certain cells are in order to get us the output we want. In this case, the highest possible. In this case, our variable cells will be the quantity of each particular bakery item. So the variable cells are going to be B4 through B7. Once you've selected B4 through B7, go ahead and click down and away. So our variable cells are going to be here. Excel is going to be able to control all of these cells right here. However, if we have it just go right now, the max could be anything. It'll just go on for infinity. We need to set some parameters, some constraints. And that's where this comes into play, subject to the constraints. Go ahead and find Add and give that a click. We've got the Add constraint box. So the first constraint, we need 400 desserts. Okay, so 400 desserts. What cell must equal 400? So I'm going to go ahead and change this to equals 400. Okay, what cell must equal 400? Well, it would probably be the total quantity of all desserts. So here, B8. B8 must equal 400. So now we're converting this sentence into an Excel phrased structure. Once you've put that into play, go ahead and click Add to move on to the next constraint. We need at least 50 of each dessert. Okay, so something must be greater than or equal to 50. What cells must be greater than or equal to 50? Well, it says each dessert. So that means all of these, cinnamon buns, cronuts, cheesecake, and brownies, must all be greater than or equal to 50. So here in the cell reference, I'm going to click and drag to select. B4 through B7 must be greater than or equal to 50. And I'm going to go ahead and click Add. The last constraint is that we cannot make more than 100 brownies. So something must be less than or equal to 100. And in this case, it says we cannot make more than 100 brownies. So this is specifically related to the quantity of brownies. B7 must be less than or equal to 100. Now that's our last constraint. So instead of clicking Add, I'm going to click OK. And there you have it. So we have our objective cell, meaning that we want to control this one cell and its output. By changing the variable cells, in this case, all of the quantity fields, Excel is going to be able to try all the different varieties of options here to find the maximum possible output for the objective subject to these constraints. No dessert may have less than 50. You must have less than or equal to 100 brownies. And all desserts must total up to 400. Once we've got all of these settings in place, the only thing that's left to do is solve. Deep breath. And check it out. So it calculated that it would need 50 cinnamon buns, 200 cronuts, 50 strawberry cheesecakes, and 100 marble brownies. So the maximum total cost possible with all these constraints in place is $1,525. Pretty cool. In order to get back to our original solver parameters, we're going to checkbox Return to Solver Parameters dialog, and we're going to click Restore Original Values. But it's pretty cool to see that we were able to set these conditions and it met all of them, and in a split second, figured out exactly what we would need in order to get the maximum desired output. Go ahead and select Restore Original Values and checkbox Return to Solver Parameters dialog to jump back. Go ahead and pause the video and take this opportunity to try this again for yourself, making sure that you follow through on all the individual steps. I'll meet you after the break. Welcome back. So that's the solver tool in a nutshell. Now, the use cases for that are enormous, but it does come with a little bit of practice. Of course, you're going to have access to these practice files after the session as well. Feel free to utilize them to get a little bit more familiar with all the tools and what they're capable of. Now, the next thing I'd like to talk to you guys about is very much in the same vein of the solver tool, which is what if? What if certain things happen? What if there are certain constraints? In this particular instance, we're looking at company sales projections based on certain sales growth quarter to quarter to quarter. With that having been said, however, there are going to be plenty of instances where certain things impact our predicted sales growth, and we'd like to be able to view all of them. To do that, we're going to need the Scenario Manager. The Scenario Manager is only available underneath the What If Analysis dropdown here inside the Data tab. So underneath What If Analysis, find the Scenario Manager. You're going to get this little pop-up right here. Now, currently there are no scenarios. So I'm going to go ahead and click Add to change that. Now, currently sales growth is predicted at 3.3% in the north, 2.3% in the east, 4.3% in the west, and 1.1% in the south. Now, we're planning potentially a rapid expansion in the south because that's our weakest market. We're talking an aggressive advertising campaign, new locations, the whole shebang. This scenario is going to be called Southern Expansion. So if the board approves our expansion into the south, we're going to be able to increase our predicted sales growth by 4%. So let's go ahead and tick date. So let's go ahead and say that in this scenario, the Southern Expansion scenario, we're going to be changing this cell from 1.1% to 5.1%. Now, of course, we do have the ability to add comments as well. And in this case, we'll say massive expansion in the southern region mass advertising campaign. In this particular instance, comments can be a really useful tool when it comes to elaborating on what these scenarios represent. Now, of course, we want to ensure that we're actually preventing changes so that we don't accidentally overwrite our current predicted sales growth. Go ahead and click OK. So go ahead and enter the value for each of the changing cells. In this case here, we'd like to change from 1.1%, or 0.011, to 0.051, indicating a 5.1% predicted sales growth. If we'd like to add additional fields, we can, but in this case, this is all I want to change. And we're going to click OK. So that's our southern expansion. Let's see what that would look like here. I'm going to go ahead and click Show. And there you go. Just like that, it's changed that 5.1%. So now I can see what Southern's yearly total could be with that 5% quarterly growth. Let's go ahead and try a different one. I'm going to go ahead and click Add again. And this time, let's go ahead and say that this is for a new potential CEO. Our company's been operating without a CEO for several months now, and because of that, morale is low. However, if we were to implement a new CEO, we could predict potentially growth in the double digits across all of our regions. So in this case, changing cells is going to impact all regions. And our comment will be something to the effect of, a new CEO will increase morale across the company, leading to higher productivity. All right. So let's go ahead and click OK. And we'll say that for each of these changing cells, we'll increase by 2%. So 3.3 becomes 5.3. 0.23 or 2.3 becomes 4.3. 4.3 becomes 6.3. And the original 1.1 becomes 3.1. We'll click OK to lock it in. So we have our new CEO, our southern expansion, and we're going to want to make sure to add our original as well. So I'm going to go ahead and click Add. We'll call this the standard scenario. This will impact the same number of cells, and we'll simply leave everything the way it was from the beginning. So we've got our standard scenario, our southern expansion, and our new CEO. By viewing each individual one, I can see how this would impact the entire company. For example, compared to the standard scenario, we're only making right now, on projected, 1,326,000. However, with a new CEO, we could be looking at 1,367,000. Interesting, isn't it? Versus the southern expansion, which puts us at 1,375,000. So it's interesting to see how this can impact how we come at our scenario projections. Now, if you'd like to get a view of all of these different scenarios, you can use the Summary tool. By clicking on the Summary tool, we can go ahead and say, hey, what's the result cell, and how would we like to report that? So in this case, I'd like to build a scenario summary based on my yearly total. Once I've selected the result cell, I'll click OK. And here we go. Based on a standard scenario, we're looking at 1,326,000. With a new CEO, we're talking 1,367,000. And with Southern expansion, we're talking 1,375,000. So, Southern expansion actually trumps getting a new CEO. It can be interesting to see how these scenarios play out, and using this information can actually help you make these kind of decisions. Not bad. Go ahead and take this opportunity to try this out for yourself. I'd like to point out very briefly that this is a new worksheet, so ensure that you get back to the original scenarios before you go too far. Go ahead and pause the video and try this out for yourself. All right. So let's keep on keeping on when it comes to what ifs. There is no greater what if than credit card payment plans. Now, I surely can't be the only one that wonders, what if my interest rate was lower? What if I paid more per month? What if I took less time to pay it off? What would my payments look like? How much would it take to pay off my current balance if I keep doing things the way I am? In all of these instances, we can actually turn to Excel to answer these questions for us. Now, we've taken this opportunity ahead of time to calculate what these payments would look like based on these projections. If the current balance is $8,000 at 14.2% APR, and you take 48 months to pay it off, the average monthly payment is $219. With that having been said, of course, we can change these details to make them a bit more realistic depending on your circumstances, maybe $6,000, maybe $12,000. But with each of these, all of the payment plans adjust. Now, having calculated that, there's plenty of what ifs. For example, what if my interest rate was 12% or 15%? What would my payments look like? Alternatively, what if my monthly payment plan was for 12 months versus 72? In all of these instances, I can actually ask Excel these what if questions, and it will handle that for me. In this instance right here, we've got a single variable data table set up. With a single variable data table and this formula already in place calculating my payments based on this data, I can actually substitute these interest rates one by one and get their predicted payment in that cell next to it. So let's go ahead and do that. This is called data table analysis. And in order to trigger data table analysis, we're going to need to highlight everything. So go ahead and take your cursor and highlight everything from the top left corner, including the payment here, down to the bottom right corner. Now, from here, we're going to need to trigger our what if analysis tool, the data table. Go ahead and find the data table and give it a click. The data table tool is incredibly simple. It's asking for a row input cell and a column input cell. Now, because this is a single variable data table, we're only going to need one variable. In this instance, when we're doing a single variable data table, that one input is going to be the column input cell. So, what cell is going to be interchanged in the column input? Which of these cells is going to be subbed out inside the original formula? And in this case, it's interest rate. We're substituting 12% for 14%, and then 12.5, and then 13. Each of these is going to take its turn substituting 14.2% interest rate to get a predicted payment. All you have to do is click OK. And there you go. We now get to answer the question, what if? What if our payment was at 12% interest? Well, then our payments would be $210 a month instead of $219. On the other side, what if it was at 15%? Well, then we're talking $222 versus $219. Pretty cool. Now, that's with substituting one variable. However, we also have the ability to substitute multiple variables. With multiple variable data tables, it's just as simple. First things first, we're going to need to highlight the entire data set. Once we've done that, we're going to need to trigger our data table tool once again. By clicking on the What If Analysis dropdown, we'll select Data Table. Now, because this is a multi-variable data table, we're actually going to be using a row input and a column input. The first thing we'll choose is our column input. Which of these values is being introduced column by column? Well, it's going to be the interest rate. We're going to take this percentage and multiply it in every single column. So this value is going to go from column to column to column, and so on. So that's where our interest rate's going to go. The next thing it's asking for is our row input cell. In this case, what are these values replacing in the original formula? In this case, they're replacing the months. So I'm going to click on the months value here inside the original formula. So I've got my row input cell, which is my months field being substituted inside the original formula. And I've got my column input cell, which is my interest rate being substituted inside the original formula. All that's left to do is click OK. And just like that, we can see exactly what this would look like. So if we took 190 months to pay off this $8,000 balance at 12% APR, we're talking $94 a month. If we took 420 months at 12% APR, we're talking $81 a month. So it's interesting to see how we can work with this here, but it's also very, very depressing to see that it would take 36, that's 25 years, I believe, in order to pay off an $8,000 balance at 12% APR, $82 a month. Wow. That says a lot, doesn't it? Go ahead and take this opportunity to pause the video and try this data table out for yourself. I heavily advise against putting your own information in there for your own sanity. I'll meet you after the break. Welcome back. So we've talked about a lot in these last couple of videos. In these last few videos, we talked specifically about asking Excel what-if questions. And we saw that there's some pretty amazing things that we can get Excel to figure out for us. We're going to shift gears a little bit, but the topic we're going to be focusing on is no less amazing. The ability to take a number of different steps and automate them using something called macros. Macros are these incredible, powerful tools that are essentially micro-programs that allow us to tell Excel step by step what we'd like it to do, and then have it do that without us having to go through the whole process every single time. This allows us to remove more tedious steps that don't have tools readily available for them. However, in order to get macros to work, we need access to the appropriate tools. There's actually a tool tab available that isn't already here. Through this entire lesson, we've had the File tab, the Home tab, Insert, Page Layout, but there's a tab that's actually been missing this entire time. The Developer tab. So we're going to need to turn that tab on. In order to turn that tab on, simply move your cursor up to the very top of the ribbon and right-click on any of the tabs. You'll see that we have the ability to customize the ribbon. Go ahead and find that Customize the Ribbon button and give it a click. On the left-hand side, you'll see some popular commands, and on the right-hand side, you'll see all of our tabs. All of them have checkboxes except the Developer tab. Consequently, this is the tab we're going to need access to in order to fully build out our macros. So go ahead and check out the Developer tab and click OK. And just like that, we now have access to the Developer tab. Go ahead and pause the video and take this opportunity to catch up. All right. Now that we've got our Developer tab on, let's go ahead and dive in and see what's what. And we see here on the left-hand side, we actually have an entire command group that's essentially dedicated to building out macros. This is where we'll be spending the remaining time focusing on. Now, what kind of macro would we want to build? The most popular macros are traditionally ones that automate some tedious process of ours. Let's do something simple. Let's say I'd like a macro that when I type my name here, or better yet, I've got a macro that will type my name, drop down a cell, type my company name, drop down, and type my email address. It would be nice if I could have a macro that did that for me. So let's go ahead and delete that. And in order to record a macro, I'm going to need to find that Record Macro button, which can be found here on the left-hand side of the Developer tab, or here in the bottom left in the status bar. Either one will work. But before I do that, I'm going to need to talk about this button right here, the Use Relative References button. Now it's important to note that when you're recording a macro, by default it's using absolute referencing. Meaning that if I go ahead and type my name here and hit enter, if I'm using relative referencing, it notes that I went one cell down. But because it's using absolute referencing, it's actually instead making a specific note about this particular cell, G2. So if I ever try to run this macro somewhere, like let's say J1, it's going to type my name, but then it's going to go straight to G2. I don't want that. I just want it to go one cell down. So you're going to need to keep that in mind. When using that kind of referencing, you're going to need to turn on relative references. So go ahead and give it a click. So we now have relative references turned on. And I'm now going to record my first macro. We'll go ahead and call this macro name my first macro. It's important to note that Microsoft doesn't really like spaces in these, so no spaces in the macro name. It's also going to ask for a keyboard shortcut key. We'll hold off on that one for now. Where do you want to store this macro? By default, it's going to store it in just this workbook. However, we do have the ability to store this macro in every new workbook. We also have the ability to store it in our personal macro workbook, where we can make it available to all documents at some point or another. For the purposes of this class, we're going to leave it in this workbook. And we're going to give it a description. Types my name, drops a cell, types my company, drops another cell, types my email. Okay, so I've got my macro name, no keyboard shortcut this time. I'm going to store the macro in this workbook only, and I've got a description. So I'm going to go ahead and click OK, and I am now recording my macro. Now it's really important to note that it doesn't really like when you click on cells, so try to avoid clicking. In this particular instance, I'm here in cell G1, and I've got relative referencing on, so that's not really going to matter. All it's going to matter is, from start, I'm going to type my name, Sean Bugler, and I'm going to hit the enter key. So I've dropped one cell down, and I'm now going to type my company name, Learnit. And I'm going to drop another cell down. And lastly, I'm going to type my company email, sbugler@notmyemail.com. Once I've done that, I've got everything done. This is all I want in my macro for now. So I'm going to stop recording using either the stop recording button up here at the top or the stop recording button here on the bottom left. Either one will work. And just like that, you've recorded your very first macro. But how do we know it worked? Let's go ahead and delete that. I'm going to go ahead and place my cursor here in cell F1, and I'd like to go ahead and run this macro. Where are my macros? Here we go. The macros button. So I'm going to go ahead and click on the macros button, and there's my first macro. All I want to do now is just run it. So I'm going to click run. Boom, there it goes. It automated my name, company name, and my email. How about that? Go ahead and pause the video and take this opportunity to try this out for yourself. Record your own first macro, where you type your name, company name, and your not email. Remember, this worked because we used relative references. So make sure that toggle is turned on. How do you know it's on? Well, when it's off, you won't see it highlighted. So keep that in mind, and go ahead and try this out for yourself. Welcome back. So we've recorded and run our first macro. Pretty cool, right? But let's say that I'm not necessarily in love with the fact that it types my email. In fact, maybe I'd like it to type something else completely. But the problem is, I've already recorded my macro. That is lost in the code forever, right? Not necessarily. However, in order to edit this macro, I'm going to need to come to terms with the fact that I'm going to be working with Visual Basic. This is very, very early days code that Microsoft used when they were first working with Microsoft Office. It's very, very powerful code. With that having been said, it's not always the most intuitive, so it does take a little bit of practice to work with. Now let's go ahead and click on that macros button again. Here I'm looking at my first macro, and what I'd like to do is step into this macro. So go ahead and click on my first macro and click Step Into. And it's automatically going to open you up into your first macro. Here's our description. And then underneath that, there's the code. You built that. Now, with that having been said, we can actually take a look at this and, using a bit of contextual analysis, figure out exactly what was going on. So here we have active cell. So whatever our active cell was, this is where it starts typing. Next, from the active cell offset by 1, meaning that it goes down 1 cell, it's now going to, using that active cell, type the word learn it. The next line of code offsets the cell by 1 again and types the email address. So this is pretty simple code. Now, if at any point I'm not in love with part of this code, I can actually work on this. Now you'll notice that it's got the description up here, but it doesn't seem to be ruining the code in any way. So how is it that this is just sitting here and it's not impacting anything? Well, if you'll notice, at the beginning of each line, there's a little apostrophe. These are what we call comments. Comments don't run. And in fact, these apostrophes signify, as Excel is running this code, to ignore all lines that start with an apostrophe. So if I don't necessarily like that it's typing my email address, I can actually go to that line of code and put an apostrophe in front of it. And see, now it's turned green. So I've commentized this line of code. Now, why did I do that instead of deleting the code? Well, I don't necessarily want to delete code that I'm not entirely familiar with. By commentizing this code, I can run it and make sure that it didn't break the rest of my macro before I actually delete the line of code. So I'm going to go ahead and commentize it. And in order to get back into it, you'll notice that we're currently inside a break. We're going to need to click that play button in order to jump back into our macro. So I'm going to click Continue. And now I'd like to get back. Notice it no longer says break at the top. So I'd like to get back into Excel. In the top left-hand corner, you'll see we have the Excel logo button. You'll also notice that in parentheses, it gives us a keyboard shortcut, Alt F11. Either clicking on that button or using the keyboard shortcut Alt F11, let's jump back into Excel. Now, in this case here, I've now edited my line of code. So, in theory, I should have removed that one line that typed in my email. There's only one way to find out, though. So I'm going to click on my macros button, and I'm going to click Run. And check it out. Where it normally would have typed my email, it now cut that line of code out completely. Pretty cool. Let's build one more style of code here. Let's say I'd like to change the formatting of this cell. First things first, I'd like to start recording. So I'm going to click on the record button in the bottom left-hand corner here. I'll call this one the formatting macro. This time I'm going to give it a keyboard shortcut of Control R. Now it's important to note that you can give this shortcut key any letter. It will override any existing keyboard shortcuts inside of Excel, however, so do keep that in mind. Don't give it a keyboard shortcut for a shortcut that you use all the time. My description will be changes the way the cell looks. And I'm going to click OK. So once again, I'm now recording, and my active cell is right over my name. So I'll go ahead and change the way this cell looks. I'll make the font, let's say 18-point font. I'll change the font style to Algerian. And I'm going to go ahead and change the font color to purple. Now what the heck, I'll center it too. So just like that, I've implemented quite a few steps here. I'm now going to go ahead and hit the Enter key to drop down a cell to do the exact same thing to the cell beneath it. So in this case here, this cell I'm going to go ahead and change to Broadway. I'm going to increase the font size to 14-point font. Also going to center this. And I'm going to change the fill color to, I think, in a light shade of blue. There you go. Now that I've made quite a few changes to this, all while recording my macro, I'm now going to stop recording. Okay, cool. So I've done it. Now let's go ahead and see what that does for me. Here in cell H1, I'm going to run my original macro. So in this case here, the Developer tab, I'm going to do Macros, select my first macro and run it. And now I'm going to place my cursor back on top of this text right here. And using my keyboard shortcut of Control-R, I'm now going to run my second macro. And check it out. Wow, that happened fast. So that macro ran on top of the existing text, and it did exactly what I did when I was recording it. Again, all of that took place because I was using relative referencing, so please do keep that in mind. Not bad. So go ahead and take this opportunity to pause the video and try recording your second macro to change your first macro's text. And then come back. Welcome back. So now, at this stage, I've got two macros, but I have to go through this whole process of running the first one. That seems a little tedious, and in fact, I might be kind of regretting not adding a keyboard shortcut for that first one. Of course, we can add keyboard shortcuts later. By selecting my first macro and clicking Edit, I can always add a keyboard shortcut here. However, I don't necessarily want to have to do that. So instead, what I'm going to do is I'm going to assign a button up here in the Quick Access toolbar to run that macro that types my name and my company. To add a button to my Quick Access toolbar, I'm going to need to click on the drop-down arrow to the right and select More Commands. For those of you that were in the first part of the video, you've already seen how we can edit the Quick Access toolbar to add some commonly used tools. However, within this, you can also add macros. By clicking on the drop-down arrow on the right-hand side from the Choose Commands From drop-down, you can choose Macros, and check it out. Here's my first macro. I'm going to go ahead and click Add, and I'm going to click OK. So now, up here at the top, there's a button for my first macro. I'm going to go ahead and give it a click to make sure it works. And there it is, instantly pasting my name and my company. So I could just do this all day. Let's take this opportunity to create a button for your first macro and toss it into the Quick Access toolbar. Once again, the way we got there was by clicking on the drop-down arrow and selecting More Commands. From the More Commands window, we selected, instead of popular commands, macros. We then found my first macro and clicked Add to add it to the Quick Access toolbar. Go ahead and try that for yourself and then come back. Welcome back. All right. So we've recorded two macros. We've edited one of them in Visual Basic. And we've created a button in the Quick Access toolbar that runs one of our macros. I'd like to show you one other way to run a macro, and that's using a button here on the worksheet. Now, in order to get this button, we're going to need to be inside the Developer tab. Here inside the Developer tab, find the Insert dropdown inside the Controls command group, and give it a click. It's here in this dropdown that you'll see that we have many form controls. Now, there's form controls and ActiveX form controls. It's really important to remember, choose from the Form Controls option. ActiveX controls are legacy tools, and in most cases, don't necessarily play as nicely with some of the newer tools as regular form controls do. Here inside Form Controls, I've got a button. So I'm going to go ahead and click that button. And I don't see a button, but my cursor is actually a crosshair. So I can actually now just click and drag to draw my button. Now, as soon as I draw that button and let go, it's automatically going to try and get me to assign a macro. If I don't already have a macro, I can record one. But in this case, I'd like to apply my formatting macro to this button and click OK. Now it says button 5. Button 5 is not really intuitive, so I'm going to call this the stylizer. Yeah, that sounds pretty cool. So I've got my stylizer button, and I'm just going to bring it over here. So now I've got my stylizer button, which should trigger this fancy stuff right here. But I'm going to go ahead and need to run my first macro to get some text. So I'm going to go up to my quick access toolbar. I'm going to run my first macro. Boom. There's my name and company. I'm now going to bring my cursor back up. And now, using this button, I'm going to run the stylizer. And there you go. I now ran a second macro using this button. Now, these are simple macros, but start to imagine all the different things that you can do. All the different dashboards you can build that are interactive, pivot tables that auto-refresh, all these different things, and it all starts with knowing that you can even make macros. Go ahead and take this opportunity to inject a button into your workbook and assign your second macro to that. And then, once you've done that, run your first macro, and then, using the button, run your second one. Pause the video and I'll meet you after the break. All right, welcome back. That brings us to the end of Excel 2016. Now, that's not to say that you know everything about Excel now. By no means. We've talked about a lot, but there's so much more to be said about what Excel is capable of. However, with the tools you've been provided, you're now capable of doing so much more than the average user inside of Excel. You can manipulate data, organize it, sort it, filter it, crunch numbers using pivot tables, ask what-if questions using the solver tool, analyze data using charts and sparklines, and automate it all using macros. Now, there are plenty of other classes available through Learnit, such as the Power User course and the Power Pivot courses that we have available. If those are things that you're interested in, click around the website. You'll be able to find them. I'd like to thank you for spending the last few hours listening to these videos. If you're listening to just this last part here, why? Why this video? But for the rest of you, thank you so much. I hope this has been worth it to you. This is Sean Bugler, and thank you so much for joining me for this video.
Thanks for watching. Don't forget we also offer live classes in Office applications, professional development, and private training. Visit Learnit.com for more details. Please remember to like and subscribe and let us know your thoughts in the comments. Thank you for choosing Learnit.